Before we get started, I received a sticker from Paul over at the Haxby Shed over in England, and I'll be very proud to add a sticker to my collection up on the board. We'll do that in a second. I met him first over at the Amateur Redneck Workshop discussion, and very interesting gentleman, lots of useful knowledge, and his channel is very entertaining and very well put together. Please go check it out. I'm proudly adding Paul's sticker as the first sticker on the new section of sticker board, and right there, Haxby Shed. Go check out the channel. Hi and welcome. So this time around we have another fixturing project. This part here needs to be held in a rotary table, and this piece will be inserted and then laser seam welded around the edges here. So the trick is to make a fixture that has the center of this shaft at the center of the fixture. However, no drawings were provided. This is a fairly complicated part, so there must be drawings somewhere, but they're not going to provide any, which means I have to figure out what the height of this guy is off the base here, because the part is going to sit in the fixture roughly like this. This piece of aluminum is what we're going to use to make the fixture. We're going to make a 1.5 inch diameter, 2 inch long shaft at the bottom that will fit in a rotary chuck, and then the top part will be faced off with a slot cut in it for this part to sit all the way on center like that. And we need to find out how far the center of this hole is from here. There is a fair amount of slop in this, so I can't really gauge off of this piece because, oh, that's interesting. It's different thicknesses on different sides. I wonder if there's a burr or something. It doesn't look like. That's kind of interesting. So these are different thicknesses. Maybe they, it doesn't look like they sand down the side either. I'm not quite sure why that is. But I think what I'm going to look for is a gauge pin to fit here very closely so I can measure from here down and then divide half the gauge, subtract half the gauge pin diameter. I don't know if it's easy to see, but looks like they peened in on 4 corners of this spot to make it hold that shaft in place, which is kind of weird. I'm not quite sure why they did that, if they're going to weld it, because the fit of this is kind of strange. Here's a 248 pin, slightly loose. 249 won't go in. Too tight, but it's only touching at the peen marks here where the material's extruded out. So I got to find out if I can file off those extrusions or they're intentional and they need to stay. I called the customer and asked them if I could remove the burrs, and they said go ahead because they're going to weld it anyways. So I removed the burrs from the 4 little peen marks, and he said the other parts don't have that. He didn't understand why this one did. So I removed it, and then I could find a much tighter fitting pin. It looks like it's 251 and change. So we're going to go with 251. I think I can get a good measurement off this. It's only a little tiny bit of wiggle. I don't think it's, maybe it's a reamed hole. Never mind, I was able to get a 252 in there. So we're going to go with 252, I guess. And then I guess I'm going to try and build a stack of gauge blocks, measure across this over here on the surface plate, and compare this to the gauge blocks till I get my height here. Then I can subtract half the pin diameter and we'll know the height from the bottom. To get a close measurement as to where my gauge blocks need to be, and probably accurate enough for this whole project, I'm going to zero this guy, and I'm just going to come up here and drop until I can just lightly catch it. So with this rough measurement, just holding this flat, dropping this down so it makes good contact, I get 0.655 from the bottom. Let's compare that and see how accurate that measurement is. A little bit bold move on my part. I'm just going to shoot straight for 0.655. And the way you do it is you start with the 5/1000s, which is the smallest digit you know, first. And so the closest thing I can get to 5/1000s is 0.105. And then I know I need 0.550 more. And so I've got that pair of blocks. Now, if I want to get it to accurate within tenths, I need to use these 10th blocks, which are 0.1 inches plus a tenth, each one 1/10, 2/10, up to 9/10. In order to use these, I'd have to drop down to 450 and then stack that on top of here. I don't think I need that kind of accuracy. So we're just going to see how close this stack up here is. Okay, I know this is a weird angle, but I've got my gauge block set here, 0.655, and you can see the meter, hopefully, that it's at 0 repeatably. And I've got it set for 1/10 per division. And so now we search for the high spot here. And it looks like it's 1,000th and 1/10 over that. So it's 0.656 and 1/10, 0.6561. So that was very useful. We were only off by 1,000th. That was surprisingly accurate. So now I take this 0.656 number, which is the height from the top of the pin to the bottom here. Top of the pin, the base here to the top of the pin, and I divide half the diameter of the pin, which is 0.252, and we have our number, which is 0.530, and we are good to go. Before I put my gauge blocks back, I clean them off to get the oils of my fingers off of them, because there's acids in the oils in your fingers, and I try not to touch them when I put them back. Now that we got our measurements out of the way, we can head over to the lathe and start making the fixture. This will be the first project I use, my new Bison 6-jaw chuck. I had the Shars, and there was nothing wrong with it except it only had one pinion, and it was driving me nuts. And for Christmas, my wife got me this Bison, which has 3 pinions, so you can walk this around and tighten each side. You get a much better grip, and repeatability improves a little bit too. So I'm very pleased with that. So we're just going to face this guy off. And then we're going to take about 2 inches of material down to 1.5. So we're going to throw away most of the bar. Kind of crazy, huh? I think what we need here is a little FaceTime. I had a weird idea. So instead of just cutting away basically, well, not basically, almost exactly half the material on this guy, which is volumetrically more than half the volume because it's the large part first, to reduce this down, 2 inches of this down to 1.5 inches diameter. Instead, I think I'm going to take an annular cutter and core out the section and part it off, and I'll end up with a little ring that I could use, you know, a little tube that I could use for something else perhaps. I don't know, it just kills me to throw away that much material, so we're going to give it a shot. It's a weird idea, I know. And that's 2 inches, believe it or not. And that leaves me just a little bit of material to take off, about 100 and something thousandths should be. I measured the inside of this annular cutter, and now I can just part off this tube and we'll be able to keep it and not waste it. Now that we've cut out the center of this guy, we can just part off the outside section here. And there we go. It was right at depth too, which is kind of interesting. I'm gonna have to face it, but that's okay. Most of the material was saved. Now I have this guy left over that I can use for another project. Seems like a good little bit of extra effort, and maybe not even a lot more time, and end up with this guy left over. So after the annular cutter is done, that was a 2-inch annular cutter. I have about 112 thousandths to come off. All right, so we're going to take off 50 thousandths pass at a pretty high feed rate, 14 thousandths a revolution. I guess it's not terribly high. Got the RPM turned up to 1120. And the feed rate's small, so I get a nice finish. And we'll just face off coming out, Tom Lipton style. So one thing to note here is that I used a sharp point and went into a relatively sharp corner. This is like a 10 or 15 thousandths radius. A sharp corner is where stress risers can be formed. So do what Max does out in Swan Valley Machine Shop down in Australia, and he radiuses the inside corner. Now this part is going to have no stress on it at all. It's just something to hold something in place while a laser welds it. So don't have to worry about stress risers. Plus is massively beefy material relative to what we're doing with it. But if you are doing something where strength is required, always remember no sharp corners, radius them unless you can't get away with it. Just a couple chamfers. And we'll flip the part around. First, we're going to take this over to the bandsaw and just cut this piece off, and we'll move on to the next part. Over at the bandsaw, I normally have this relatively fine-pitched blade on here, and I think for this thick a piece, I'm going to switch to a much coarser tooth blade. It'll cut faster and less clogging up. As you can see, I've gone for a much more aggressive tooth pitch. This is a 4/6, and it was a 10/12 before. And so we're going to cut this guy off about 0.8 of an inch. And a little bit of chip loading. Cutting like butter is too much force on the blade, I think. For aluminum, I had it left, it's steel. Yep. Definitely need something to clean the blade just to get the chips out. I often sit here with this metal stainless steel brush just to clean chips before it enters the cut. And with these 6-jaw chucks, you often have to re-zero them for each diameter. Well, actually, that's what you need to do if you want to be really accurate. However, this one with the 3-pinion design tends to be closer, and as you'll see, I'm only 1/1000th off. And I've changed diameters significantly. I was held on the outside part 3 inches. I'm measuring on the 1.5 on the inside, and I'm only 1/1000th off. That's very impressive. Hey, scratch my nice surface by bunching up chips. Thank you very much. Always appreciated. All right. Now let's clean up the face here. And strictly, that should be enough for this part before I take it over the mill, except that why not take advantage of the fact that I know exactly where the center of this is and mark it, make it easy to find. So I'm going to take and drill and ream to 1/4 inch right down the center of this part. So when I get over the mill, it'll be very easy to find the center. Just a little shortcut. So we want this hole to be accurate. So we're going to start with the center drill. And ream. I'm actually going to have 2 ways to find center now. The pin is going to be the backup. So first, I go and find my halfway point between jaws because I'm just gripped straight in the jaws. And I get 0.6458. I always double check. I go back to the other side, make sure I get exactly the same the other direction. Within 4/10, that's very good. So we're going to come to 0, which should be the very center of that part. And I can come up and I can go and divide X by 2 as well. Let's just see what we get here. We'll call it X naught. 1.5933. Double check. Now I could go and repeat this, but instead we're going to shoot for our 0, 0 here. and we'll drop a pin in and see how it fits. That should be a pretty close fit. So drill chucks have a little bit of run out. This is not the most precise way to do this, but it should go right in, which it does. Very smooth, which tells me that my center finding was correct. All right, so I helped myself out with a drawing here. So for starters, because the corners, the end mill won't be able to get into the corners, I'm going to drill some 1/8 inch holes, which means I'm going to need to finish with an 1/8 inch end mill going around here. So I'm going to drill 2 1/8 inch holes, at 0.312 off center, 0.530 off center. Everything's relative to center. When I'm milling this out with my 1/2 inch milling cutter, I made the calculations really easy by just laying out a 1/2 inch cutter in CAD and figuring out what my plus or minus off center line is, and it's 0.280 this direction all the way off the end of the part in this direction, and plus or minus 0.062 in that direction. So that makes it really easy. So for starters, might as well drill the holes. 0.260 and 0.312 plus or minus. This is 1 size over 1/8, so I shouldn't have any problem. Now we go to minus 0.312, drill the other. So we're going to start with a 1/2 inch end mill and just clear out the majority of material, and then we'll come back with an 1/8 inch end mill and clean it up. Makes me think that I did the wrong measurement when I drilled. I'm kind of annoyed at this because I think I did. I need to go 0.280 past center. 0.530 past center for the drill holes, and I think I was looking at the wrong part of my drawing. Brilliant. Well, so this isn't the way it's supposed to be up, but the thickness of the walls varies. It's tapered, so it's tight this way. It's a perfect fit this way. It's exactly what I'd like to see, but unfortunately the part's tapered, so I'm going to have to give it some slop, and then it's going to kind of rattle around. That's disappointing. I'm going to go to a 1/4 inch end mill and then finish with an 1/8, because 1/8 is so delicate it's likely to break. So we need to go to 0.405 total depth. So I got my initial holes in the wrong spot because I'm an idiot. That was brilliant. I'm going to try and correct it now. So we're going to go 0.530. I went 0.280. I read the wrong part of my drawing. 0.530, and it's plus or minus 0.312. So we'll see if we can plunge down right here in the corner. That looks right. Well, I wasn't careful about the metrology, and I missed something. Maybe you could see it. I assumed this hole was centered in this direction. It was not. I completely missed that. Man, is that frustrating. Now I got to start all over again. That was really stupid. Here's the part finished, and it came out much better than last time. This part had been dropped, not by me, strangely enough, because I drop everything, but it had been dropped, and there was some metal displaced out, and that's why it was fitting so tightly. I took it over to my surface plate with sanding paper on it and sanded that off, and now we got a perfect fit, and it looks like it lines up nicely. So for each one of the different end mills I used, the 1/2 inch, the 1/4, and the 1/8, I wrote down how much I had to go in each direction to make sure the part was right. And it worked out great. And I did it in CAD as well to do the shortcut, but I verified it with a calculator because after I screwed up last time, I didn't want to risk it again, and I double checked my hole placement. Strangely enough, my y-axis on the DRO was off twice and I had to recalibrate. I'm not sure why. I don't know if that was because I was not in ALE mode or something. I'm really not sure what happened there, but so I double checked. And having this center hole here that I drilled as a reference was really handy to have. It really helped me to get these parts going and verify that I was still centered properly. That's how I knew I was off. When things weren't lined up over that hole, I could tell. And that hole mirrors this hole here. So I'm very happy with how that turned out. All right. Well, I think this is a successful project. I hope the customer's happy. Thanks for watching. Hope you find it useful. Hope to see you next time.